Welcome to Kanerika's podcast, The Digital Shift. I want you to imagine for a second waking up, grabbing your morning coffee, and opening an automated alert that your company just incurred a $50,000 cloud infrastructure bill overnight.
Oh, wow. That is a pretty terrifying scenario.
It really is. And why did it happen? Well, because a well-meaning junior analyst ran a single unpartitioned query that scanned petabytes of enterprise data while you were sleeping.
It sounds extreme, but it happens far more often than executives want to admit. We have officially moved past the era where data storage was just a passive, cheap utility.
Exactly. I mean, now that we are in 2026 and your enterprise data scales into the petabytes, choosing the brain of your data operations is no longer just a routine IT ticket.
Right. It is arguably the most consequential financial and technological decision a company can make today.
So we are going deep into the data ecosystem to analyze the two undisputed heavyweights in the modern cloud data warehouse landscape. We're talking about Google BigQuery and Snowflake.
And our mission today is to really look under the hood. We will examine their underlying architecture, decode their pricing models, and explore how they are integrating artificial intelligence.
We will also evaluate their security profiles. By the end of this discussion, you will know exactly which platform fits your specific enterprise workloads.
And to make that determination, we have to start at the absolute foundation, which is the architecture.
Right, because how a system is fundamentally built entirely dictates exactly how you pay for it.
Exactly. I mean, the economic models of BigQuery and Snowflake aren't just arbitrary pricing tiers. They are direct reflections of how their engineers design the plumbing.
So let's unpack BigQuery first. BigQuery operates on a fully serverless design.
And for a data engineering team, that sounds like an absolute dream. There are no clusters to manage, you have no hardware to provision, and you never have to manually scale your infrastructure.
Because Google handles the compute allocation dynamically in the background. But that architectural choice completely dictates the bill, doesn't it?
It absolutely does, because you pay purely for the data scanned during your queries. Their standard model charges $6.25 per terabyte of data scanned on demand.
Though, they do give you the first TB byte free every month, which is nice.
They do, yes. But the crucial mechanism to understand here is that your primary cost driver is not how long a compute engine runs. It is how much data your query actually reads.
Wait, so going back to my nightmare scenario from the intro, if I execute a simple query, but I run it against a massive unpartitioned table with 10 years of global sales data, I pay for scanning that entire massive table.
You do, even if the answer comes back in 2 seconds.
Ah, wow.
Yeah, that is why data partitioning and clustering are absolutely critical in BigQuery. If you don't engineer your tables to limit the amount of data scanned, your costs will skyrocket. It requires a very specific discipline from your data team.
Okay, that makes perfect sense. So let's look at Snowflake, which takes a radically different architectural approach. Snowflake physically separates storage from compute.
They do, and this was revolutionary when they introduced it. In Snowflake, your actual data sits quietly in cloud object storage. But the processing, the heavy lifting, happens in what they call virtual warehouses.
And those are like independent engines, right?
Exactly. Think of these as isolated compute clusters that you turn on, scale up, and turn off. You pay for the virtual warehouse runtime, with compute credits ranging from about $2 to $4, depending on your tier.
But you only pay when those clusters are actively running.
Right. And separately, you pay for your storage footprint, which is roughly $23 per terabyte per month for compressed data.
Speaking of compressed data, that compression ratio is a massive financial detail, isn't it? I know we see this a lot in our own architectural reviews.
It is huge. Snowflake achieves a highly efficient compression ratio of about 3-to-1.
So how do they mechanically achieve that?
Well, they do this through something called micro-partitioning and columnar storage. It automatically packs the data down tightly without you having to configure it at all.
That is incredible. So if you are migrating 30 terabytes of raw enterprise data, it actually bills as only 10 terabytes of storage on your monthly invoice.
Exactly. It changes the cost equation entirely.
I want to make sure we're giving you a clear mental model of this. Think of it like this. Snowflake's architecture is a bit like a massive national library. The books, which are your data, represent the storage. You pay a flat fee to keep the books on the shelves.
I love that analogy.
Right. And when you need to read them, you hire independent research assistants, and those are your compute warehouses. You can hire one assistant or 50, and you only pay them for the hours they spend reading.
That is spot on.
Whereas BigQuery, on the other hand, is like a massive, highly dynamic buffet. You could sit in the restaurant all day for free, but the moment you put food on your plate, you pay precisely by the pound for whatever you consume.
That is a perfect way to look at it. And, that library analogy is great for Snowflake, especially because it perfectly explains our next critical topic, which is performance and workload isolation.
Right, because these distinct architectural blueprints mean each platform handles heavy corporate traffic in completely different ways.
Exactly. A modern enterprise doesn't just run one query at a time. They have thousands of concurrent operations.
So let's look at BigQuery's performance under pressure. Because BigQuery allocates compute dynamically from Google's massive shared pool of resources, it is incredible at handling unpredictable concurrency spikes.
It really is. If your company suddenly goes viral or it is Black Friday and you have massive variable spikes in analytical demand, BigQuery's shared pool absorbs that demand seamlessly.
So you don't have to manually spin up larger servers.
Not at all. Google just throws immense compute power at the problem behind the scenes to execute massive parallel scans.
Well, hold on. Let me play devil's advocate here for a second. If it is a shared pool, what happens when internal traffic gets jammed?
What do you mean?
Well, say I have an enormous data engineering team running heavy ETL operations. They are extracting, transforming, and loading terabytes of messy data at the exact same time my executives are trying to refresh their real-time financial dashboards. In BigQuery, aren't they technically drawing from the same pool? Which architecture actually prevents a traffic jam?
That scenario is precisely why many enterprises lean towards Snowflake. Snowflake's architecture prioritizes strict workload isolation.
So going back to the library analogy.
Exactly. Your data engineers and your executives are using completely different research assistants who never talk to each other. You literally assign the engineering team their own dedicated virtual warehouse for those heavy ETL jobs.
And then you spin up a completely separate virtual warehouse exclusively for the executive BI dashboards.
Exactly. They operate completely independently against the same centralized data. It totally eliminates the resource contention that traditionally plagues large shared data environments.
So mathematically and physically, the heavy data loading happening in the background can never degrade the performance of the analytics the executives are viewing.
Right. No matter how hard the engineers are hitting the database, the CEO's dashboard still loads instantly.
That isolation is brilliant for traditional analytics, but, performance today isn't just about how fast a bar chart loads. We have to talk about how these platforms process the defining technology of 2026, which is embedded artificial intelligence.
Oh, absolutely. Both of these giants have realized that you cannot keep pulling data out of the warehouse to train AI. You have to bring the AI directly to the data.
And this is where the philosophical divergence between Google and Snowflake becomes really fascinating. Enterprise data teams are now running inference, summarizing text, and generating embeddings natively within the warehouse itself.
Let's look at BigQuery's approach first. BigQuery is naturally deeply intertwined with the Google Cloud ecosystem. They have natively integrated Gemini directly into the warehouse.
So developers can literally just write standard SQL and use native functions.
Yes. They can use functions like AI.generate or AI.embed. Plus, it links directly with Vertex AI for custom machine learning model training.
That depth of integration is incredibly powerful. I mean, if your enterprise is already heavily invested in Google infrastructure, you have the entire Google AI machinery available without ever leaving your data environment.
Right. Snowflake, on the other hand, has built Cortex AI, and they have taken a multi-model approach. They let you access an impressive roster of foundation models directly via SQL without moving your data.
And what models are we talking about here?
We are talking about Gemini 3 Pro, Gemini 2.5 Flash, Anthropic's Claude, Meta's Llama, Mistral, and OpenAI, all available directly within Snowflake.
That is an unbelievable roster, but let me push back a bit on the paradox of choice here. Is it actually an advantage for Snowflake to offer so many different models, or does BigQuery's hyper-focused, deep integration with Google's Vertex AI create a more stable environment for developers?
That is the ultimate trade-off, It is a choice between Google ecosystem depth versus Snowflake's model-agnostic flexibility. Snowflake gives you a very future-proof architecture.
Because you aren't tied to one provider.
Right. If a brand new, vastly superior foundation model drops next month, Snowflake's architecture allows you to adopt it instantly, right on top of your existing data. You avoid vendor lock-in at the AI layer.
But on the flip side, BigQuery gives you a frictionless, unified pipeline if you are willing to commit to the Google way of doing things.
Precisely. If your teams are deeply trained in Google's specific pipelines and you're building bespoke, custom models in Vertex AI, BigQuery removes a lot of architectural friction.
Now, you just mentioned doing all this securely on top of the data. Because these AI models are only as good and safe as the data they can access, we need to examine where this data lives and how it is governed.
Without a doubt, ecosystem strategy is not just a technical detail anymore. It is a board-level conversation.
So true. If we look at the ecosystem footprint, Snowflake is natively multi-cloud. It runs organically on Amazon Web Services, Microsoft Azure, and Google Cloud Platform.
And that multi-cloud architecture enables one of their most powerful features, which is the Snowflake Data Marketplace. It allows for live, cross-cloud data sharing without any physical data movement.
I want to highlight how mechanically wild that is. That means a supply chain team operating entirely on AWS can securely share live inventory data with a retail partner utilizing Azure instantly.
Yes, and the crucial mechanism is that the data never actually moves. Snowflake just securely grants access pointers across the clouds.
Which preserves data integrity.
Exactly.
Yeah.
And it completely eliminates massive data egress costs, which are the fees cloud providers charge you for moving data out of their network. BigQuery, conversely, is natively rooted in the Google Cloud Platform.
Now, to be fair, Google does offer BigQuery Omni to extend its reach, right? It lets you run queries against data stored in AWS and Azure.
It does, but it is not a native multi-cloud deployment in the same fundamental way. Omni relies on cross-cloud network calls. While it is a great feature, it inevitably introduces latency and some egress trade-offs that Snowflake's native pointer-based sharing avoids entirely.
Which brings us to the natural tension point of multi-cloud environments, and that is security. If data is suddenly accessible across AWS and Azure, how do we prevent a massive compliance violation? How do these two platforms manage governance?
Both are incredibly robust, but they scale quite differently. BigQuery leverages Google Cloud's standard IAM, which is Identity and Access Management, along with Virtual Private Cloud, or VPC, infrastructure.
And is that enough for highly regulated industries?
It is highly secure, and crucially, it now supports IPA compliance, even for its advanced conversational analytics features.
Okay, and what about Snowflake?
Snowflake approaches security by offering highly scalable, specialized tiers. They provide a business-critical edition specifically engineered to support stringent IP, PCI, and SOC compliance out of the box.
But what if you have extreme security requirements, like, say, federal government or top-tier banking?
For that, they offer Virtual Private Snowflake, known as VPS. VPS actually gives you dedicated hardware and the absolute strictest tenant separation available in any major cloud data warehouse today. You are physically walled off.
Okay, so understanding these architectural differences, the AI trade-offs, and the security profiles is vital. But let's get real for a moment. The true barrier for any enterprise is not picking the software. It is the migration reality.
Oh, absolutely. Moving a massive legacy on-premise system into one of these modern giants sounds like doing open-heart surgery while the patient is running a marathon.
It is notoriously difficult, and historically, it is where digital transformations go to die. And this is exactly where our team comes in. We at Kanerika are uniquely positioned to help your enterprise evaluate, migrate, and optimize these exact systems.
Right. We don't just offer theoretical advice. We at Kanerika engineer the actual transition. We bring deep cross-platform delivery expertise to the table, backed by elite industry credentials.
Exactly. We are a Snowflake Select Tier partner, a Microsoft Solutions partner for data and AI, and a Databricks consulting partner. That cross-ecosystem expertise means we design architectures that serve your enterprise's specific needs rather than just forcing a single software vendor's agenda.
And, the absolute crown jewel of our migration methodology is our proprietary migration accelerator.
Let's talk about that. We call it the flip accelerator, just like the verb to flip a switch, and it literally flips the script on complex, painful data migrations.
We really need to explain how the Flip Accelerator works because it is not just a marketing buzzword. Historically, migrating an enterprise data warehouse meant locking 20 developers in a room for a year to manually rewrite thousands of lines of legacy business logic and custom SQL.
It was a nightmare.
Yeah.
So how does the Flip Accelerator change those mechanics?
It fundamentally alters the mathematics of a platform migration. When we execute a migration at Kanerika, we use the flip accelerator to handle incredibly complex legacy ETL conversions automatically.
So it is not just doing a basic find and replace.
Not at all. It doesn't just copy and paste. It actually parses the underlying abstract syntax trees of your legacy code. Then it intelligently translates the logic for the specific syntax of the target platform, whether that is Snowflake or BigQuery, and then it validates the output.
It is essentially an automated translation engine for your deepest, most complex business rules. The efficiency gains are just staggering.
They really are. By utilizing the flip accelerator, we reliably reduce the total migration effort by 50 to 60%.
And more importantly, to your bottom line, we are cutting project delivery timelines down to just 2 to 8 weeks for most complex enterprise workloads. We take multi-year migration nightmares and turn them into highly predictable, rapid deployments.
Because speed to value is the only metric that truly matters. You cannot put a freeze on your business operations for a 2-year infrastructure migration. You need the modern capabilities like the AI integration, the workload isolation, activated immediately.
Let's ground this in reality. To prove the value of these rapid, highly engineered migrations, let's look at the actual business implications we recently delivered for a client. We partnered with a global medical technology company that operates right at the cutting edge of clinical decision-making.
And their operational reality before our Kanerika team stepped in is a scenario I think a lot of enterprises will recognize. They were severely constrained by disparate, heavily siloed data sources scattered across different geographic regions.
Right. Their data mapping was inconsistent, and they were relying on completely subpar, slow healthcare dashboards.
They had the data, but they simply couldn't see it clearly. Their legacy setup was fundamentally hindering their ability to make rapid, accurate decisions that directly impact patient care.
So we architected a complete turnaround. We utilized Snowflake to centralize and standardize their global data mapping.
And by leveraging Snowflake's architecture, we immediately eliminated those regional data silos. This provided a single, unified, governed view across all of their operations.
Then we layered an intuitive, highly responsive Power BI interface directly on top of that Snowflake backend. We designed it specifically so their healthcare professionals could explore complex data without any technical friction.
The operational statistics resulting from this transformation really tell the whole story. By centralizing the data and deploying those intuitive dashboards, this global medical tech company achieved a 25% increase in data-grounded decisions across the organization.
That is massive.
It is. And they recorded a 40% decrease in operational response time. And perhaps most impressively, they saw an astonishing 61% reduction in the time required to retrieve critical information.
Wow. That is the real-world impact of moving from a tangled legacy system to a properly engineered modern cloud data warehouse.
It perfectly illustrates our core philosophy. Infrastructure decisions are ultimately human performance decisions. When you remove the friction from data retrieval, you empower your entire workforce to operate with unprecedented speed and precision.
As we bring this analysis to a close, let's distill the core takeaways for your enterprise. If you are leading a natively Google-aligned team that desires serverless simplicity, or never want to manage a cluster again, and you crave deep, seamless integration with Google's Vertex AI ecosystem, well, BigQuery is an absolute powerhouse for your infrastructure.
Conversely, if your enterprise demands true multi-cloud flexibility, the ability to share data across clouds without physically moving it, and the strict workload isolation required to run massive engineering pipelines and executive reporting simultaneously without any friction, Snowflake is the undisputed champion.
Whichever path aligns with your strategic vision, we at Kanerika are ready to partner with you. We don't just guess. We are prepared to run a comprehensive custom workload analysis and a highly detailed cost model simulation based on your actual data footprint.
We can help you make the perfect architectural choice with total financial clarity. We ensure that your transition into the modern AI-driven landscape is calculated, mathematically optimized, and flawlessly executed.
The digital landscape is shifting fast, and your data foundation will completely determine your ability to adapt. Which leaves us with a compelling, forward-looking question for you to ponder independently.
As artificial intelligence agents become increasingly autonomous, deeply embedded within these modern data environments, what happens next?
Will the data warehouse of the 2030s stop being a place where we simply store information and instead become a digital employee that actively runs the company while you sleep?